Hey guys, welcome back to my channel. Thank you very much for joining me. For today's video, we are going to talk about the characteristics of your polynomial function. So right here, I went ahead and I graphed the function on the board. It's not drawn to scale, so all the curves are not there, but it is relatively what it looks like. Excuse me. So this function is called negative x cubed plus 6x squared minus 10x plus 4, and the graph of it looks like this. So characteristics of your function could be its range, domain, the maximum and the minimum points. It could be your end behavior. It could be the increasing and the decreasing intervals. So when it comes down to these, you have to know a little bit about your graph. All right, so let me change my color here. Let's talk facts. So we're asked to find the domain of our function. We know domain are x values. And so we look at the function to see where the x values are, where it's trending. Did it start one place? Did it stop one place? Like what's going on? So we know our x-axis is our horizontal axis, positive and negative, and the y represents our range as well. So let's talk about that for a minute. So here, you look at the function, you see that x is increasing in this direction. So as x gets bigger, the function here gets longer. So we see x continues into positive infinity. But on your left hand side, you see as you go along the x-axis, the y value, which is the graph you're seeing, is going to be extending upwards. So we're going to say it's going to be all real numbers because it doesn't stop. The more x you add to this function is the longer your graph is going to be. Okay, so for the range, we know range are y values. And y values are on your vertical axis, like right here, as you see me labeling mine. And so the same thing happens. You look at your function to see if it's going upwards, if it stop at a particular point. In this case, the arrows meaning that they continue on to infinity. So we're going to say all real numbers. Alright, so when we talk about the relative max and the relative mean, this is basically what are the high points and the low points on your graph. Sometimes you may have more than one of them. Then you use some different terms to describe those. But in this case, we have two turning points. So we have turning point like one here, and we have a turning point one here. So when it comes down to the relative max and the relative mean, it's basically you identifying the highest point between the nearby values. So here we have the highest point at the peak. I'm going to change the color a little. Highest point at the peak. Oops, my bad guys. And let's say our highest point is like right up here. The lowest point is going to be like right down here. But between these neighboring points, if you should pick out 2 points that's covering or between the highest point, you realize that among these 3 points, this point in the middle would be the highest one because that's where the graph is changing its direction. And so right here will be our peak. Based on our graph here, the peak could be 1, 2, 3, almost 3. It's not that 3, so I would say 2.8 something, and that's the max. So my x value is 2.8. Not approximate exact value, guys. Your graph calculator will give you the exact thing, but right now I'm gonna say 2.8 for x because it's like trending somewhere right here, almost to 3, or 2.9 could also go. And for your y value, it's a little bit above 1, so maybe gonna be like a 1.1 or a 1.2. So right there, your relative max at this point has an x value and it has a y value. All right. So for the relative minimum, you do the same thing. Once you can see 2 points within that point and you identify, you can go ahead and see that that's the minimum value. And again, we identify the x values and the y values of that function. So right here, it has an x value and it has a y value. So x here to me seems to be 1. And the y value seems to be almost 1. I would say at 0.9 because it didn't reach 1. I'm going to say at 0.9 negative. So that's my turning point right here. All right. So when it comes down to your increasing and decreasing intervals, you can always think about climbing a hill. You're moving from point A to point B, but we only focus on the x values of that movement. So you look at your graph and you see if the graph is going upwards or if it's going down. Then you can always tell when something's going up or down. So like this function here, this line here is going this direction. And how do I know? Because the function is leaving from that direction, it's going that way. So right here, this one is increasing. So I'm going to put my green as my increasing interval. And if you see it's going down, for example, let me change the color again so to give you a distinction. This line you see me drawing here, that's basically trending down. This other graph here is also trending down. So even though the arrow is pointing upwards, that's basically covering your range. But if you look at it, you see a function, one is negative, so it's not coming from its positive direction, it's coming from the negative. So it's going to be trending down, it's going to climb, and it's going to go down again. Alright? So your leading coefficient can always give an idea if it's going up or down as well, if you look at that, if you want to look at it like that. Alright, so we say this is decreasing, and we say this black line here is also decreasing. Alright? So we tell the x values of where it's decreasing from. So this one here, you see, goes into infinity.